Let's draw the Lewis structure and determine the VSEPR geometry for chlorine trifluoride. These are all halogens, so they all come in with 7 valence electrons. There's 4 of them, 3 fluorines and 1 chlorine. That gives us a total of 28 valence electrons to draw this Lewis structure with. Chlorine is less electronegative because fluorine is the most electronegative element. Put chlorine in the middle, surrounded with 3 fluorines. Let's connect them, the terminals to the central. That's going to, each of those bonding pairs is going to eat up 2 electrons. So we're down to 22 valence electrons. Next, let's give the terminal atoms an octet. Each of the fluorines already has 2 valence electrons in the bonding pair shared with the chlorine. So they each want 6 more. That's going to use up 18 more, and we're down to 4 valence electrons. We can put them on the central chlorine, which is a period 3 element, which means it has d orbitals it has access to. We can give it an expanded octet. Let's check out the formal charge. They're all zeros. The formal charge is our attempt to put a charge on each atom in a molecule. You get the number of valence electrons in the normal neutral state. Subtract the number of dots, that's the number of non-bonding electrons, and then subtract the number of lines, which represents its share in each of the covalent bonds. Do that, and you'll see the formal charge for all of these atoms is 0. Alright, so this is the Lewis structure. Finally, let's work on the VSEPR molecular geometry. The central atom here is chlorine. So let's count up the number of effective pairs, or the number of electron densities. 1, 2, 3, 4, 5 effective pairs. So all 5 of those pairs of electrons want to maximize their separation in order to minimize their repulsion. Because they're negatively charged particles, they repel each other. So the best way they can minimize the farthest they can get away, if you have 5 regions, is trigonal bipyramidal. Now, the lone pairs are not part of the building, the structure, but they help determine the structure. So because we have 2 lone pairs, the molecular shape is T-shape. Now those bond angles are going to be slightly less than 90 because of those extra repulsion by the lone pairs. I'll draw that a little bit bigger here. So here's chlorine. We're going to put fluorine on the plane of the screen, all 3 of them. I'm not going to draw the valence electrons. Well, actually I will. Alright, and this pair of chlorines, let me go this way. This pair of chlorine's electrons are coming out of the screen, and this pair is kind of going behind the screen. Right, but they're not really part of the structure. So this is the T-shape of the molecule. But these the lone pairs help determine that shape, because they're the ones repelling them into that T-shape. Right, so the bond angle here is less than 90 degrees because of that extra repulsion. So this molecule does have a net dipole because this chlorine-fluorine bond is a polar bond. Okay, so there's a dipole there, there's a dipole moment there, and there's a dipole moment there. So there's a net dipole this way. Okay, so it's a polar molecule.